Assalamualaikum warahmatullahi wabarakatuh. This video is recorded to present our group project for ISP565 data mining. For this project, we chose diabetes 130 US hospitals for years between 1999 to 2008. First of all, I will introduce our group members, starting with ANIZ ZULAIKHA binti ZAMRI, AIMAN JAMIL, NURFATIN binti SULAIMAN, SITI NABILA and me myself is MARIANA binti MOHAMED ZAIDI. As mentioned before, we use diabetes 130 US hospital for years starting 1999 until 2008 dataset downloaded from UCI Machine Learning Data Repository. The dataset represents 10 years of clinical care at 130 US hospitals and integrated delivery networks. This multivariate dataset has 50 attributes and 101,766 instances. As the project requirement, the dataset contains missing values and incomplete or inconsistent records. In this project, we use classification techniques as methods, and the project is done using WEKA GUI Explorer.
Assalamualaikum, my name is NURFATIN bin JAMIL. So I will explain about the data cleaning that we have done. In this data cleaning, we have done several processes which are study the numeric and nominal attributes, identify the missing values, identify attributes containing noise, and identify attributes with outliers using WEKA. So there are 13 number of numeric attributes in this dataset, and its minimum value, maximum value, mean value, and its standard deviation value. For nominal attributes, there are 34, and its value and total count. So next is missing values. So any missing values in this dataset will be removed using replace missing value filter under unsupervised and attributes. So any missing value will be replaced to a suitable values using WEKA. So next is noisy data. Noisy data is a useless data and is sometimes used similarly with corrupted data. So noisy data is the attributes there is not nominal or numeric attributes. So we have identified 3 attributes that containing noise, which is the 19th until 21st of attributes, which we key in the attribute indices 19 to 21 using the remove filter under unsupervised and attributes. So next is detecting outliers, or we can call as extreme values, which is a data point that does not match the rest of the data. So to identify the values with outliers, we use interquartile range filter under unsupervised and attributes. So the result will be shown on the right figure, as you can see. So any values that contain yes on the outlier and extreme value will be deleted using remove with value filter under unsupervised and instance. So this is the result when all the values that contain yes on the outliers in the dataset. So from 8,000 of values are removed, and same goes to the extreme values. There are around 23,000 of values that have yes on the extreme values have been removed. So this is the sample of the dataset that have been cleaned.
Assalamualaikum warahmatullahi wabarakatuh. My name is NABILA. So now I will continue with the A3 data preparation transformation. So first we go to the normalized attributes. So we choose the min-max normalization with range of 0.0 and 2.0. We choose the filter of normalized from filter, unsupervised attributes, and then normalize. So for the setting, we choose scale of 2.0 and translation of 0.0. This is to normalize all the numeric attributes with the maximum and minimum value 0 and 2. So next is discretization attributes. This step is to change from numeric attributes to nominal attributes. So we choose the attributes of admission types ID with bins of 8 because this attribute has 8 labels. So we choose the filter of discretize, which is from the filter unsupervised attributes and then discretize. So as we can see here, these types from the numeric turns into the nominal after we discretize the attributes. And then we change the label that given from WEKA into the easier label for us to read. So next is attributes construction, that we add an attribute with the sum of 5 existing attributes. So we use time in hospital, num procedure, num medication, num lab procedure, and num of diagnosis to make the severity of disease. And then we use the filter of add expression, we use the filter unsupervised, and then attributes, and then add expression. So from the setting, the expression with the A10, A14, plus A15, plus A13, and plus A19. This expression stands for attribute 10, which is where the attributes stand in the WEKA. And the name is the name for the new attributes, which is the severity of disease. And then this is the result of the created attribute, which is the severity of disease. So now I will pass it to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURFATIN. For our group project presentation, I will be continuing part A for data reduction for further explanation. To go through data reduction, we need to rank our attribute first for this dataset to see which attribute that does not have any beneficial impact on the class attribute which are re-emitted. So we need to click on the select attribute tab, choose info gain attribute eval for the attribute evaluator, and choose ranker for the search method. This tab will evaluate and rank the attributes from the very important attribute to the least important attribute. Total 37 attributes are removed based on the ranking list and by using the remove button function in pre-processing. So as you can see in the slide, this is the reduced data. This is the reduced data set. 13 attributes are left after the reduction process. The new dataset, which is reduced dataset, are also shown in the slide. So in this step, I will be explain J48 classification that are performed on the reduced dataset to obtain better accuracy result. So the first one is cross-validation care fault 10. The accuracy is 58.6427%, which is higher compared to the full dataset performance. The incorrectly classified is 41.3573%, and the total confusion is 41020. So to obtain this accuracy result, we need to go to the classified tab and choose J48 classifier under trees and set the fault to 10 in the cross validation. So we click start and we can get the result as shown in the slide. Next, change the number of fault to 20 and then run the test again by clicking the start button. The results are also shown in the slide with the accuracy of 58.78%. The incorrectly classified is 41.22%. So, from both of the tests on previous slide, which perform classification on full dataset, the total confusion matrix and accuracy is increasing from full dataset to reduced dataset. For the third test on reduced dataset, we perform a classification techniques by splitting the percentage into 70% and 30%. So this ratio is commonly used to split the percentage into training and testing dataset. So we can conclude that accuracy achieved is 58%, with the incorrectly classified is 42%. So the last one, the reduced dataset are divided into 80% for training dataset and 20% for testing dataset. So based on the slide, the accuracy obtained for the training set that we perform classification on the reduced dataset is 58%, and the incorrectly classified is 42%. This is the tree visualization for reduced dataset. Since the dataset have thousands of number of trees and size of leaf, the visualization shown as in the slide. The graph shows a comparison between full dataset and reduced dataset. From the graph, it shows that there is a difference between the accuracy percentage of full dataset and reduced dataset. For cross-validation K-fault 10, the full dataset achieved accuracy of 57.55% and reduced dataset achieved 58.64%. While for cross-validation K-fault 20, the full dataset achieved less accuracy compared to the reduced dataset, which is 58.78%. For percentage split into 70-30%, the accuracy result for full dataset and reduced dataset are 57.25% and 58.21% respectively. And the last one is percentage split is 80%. The full dataset achieved 57.51% for accuracy result and 58.46% for reduced dataset. So for the references, we use a dataset from UCIML data repository, and there are 2 articles that we use for our group project. Thank you.
Assalamualaikum. My name is ANIZ ZULAIKHA binti ZAMRI. I would like to present about model development and evaluation, which is classification method. Before we do cross-validation, we must insert the dataset file into preprocess tab. Then we click classify tab. Then we choose, then we filter and choose trees, and then we click J48. After that, we check cross-validation. Then we type K10. The fold is K10. Cross-validation is a statistical method that used to estimate the skill of machine learning models. The value for K is fixed to 10 that get accuracy, which is 57.5405%, and incorrectly classified is 42.4595%. The correctly classified instances get 40249, while the value for K is fixed to 20 that get accuracy is 57.6992%, and incorrectly classified get 42.3008%. Then the correctly classified instances get 40360. We are using J48 decision tree classifier in WEKA. Okay, next. In the testing option, we using percentage split as our preferred method. The split used is 70% train and 30% test. Our understanding is that when we use J48 decision tree, it will use 70% of our set to train the model and 30% to test it. Then the accuracy got 57.2457%, and for the incorrectly got 42.7543%. The correctly instances got 12013. And then the idea is that fitting the model to 70% of the data is similar enough to fitting it to all the data for the performance of the former procedure in predicting for the remaining 30% to be a decent estimate of the performance of the latter in predicting for unseen data. While for split use 80% trend and 20% test, the accuracy got 57.4053%, and the incorrectly instances got 42.5947%. Then the correctly classified instances is 8031. This is a tree diagram before reduction. A tree data structure is an algorithm for placing and locating files called records or keys in a database. The algorithm finds data by repeatedly making choices at decision points called nodes. That's all from me. Thank you.